Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to have you to step into my virtual math classroom as we learn some more math stuff. Today's math stuff is going to be evaluating algebraic expressions when your variables that you have is known. So what you'll have is a string of an expression, letters that are squared and minused and added with the parentheses and all the little bunch of stuff, and we're going to substitute in a quantity for a variable that's negative or positive or maybe zero. I don't think I've seen zero. And then we'll go through those. You're going to see a list of numbers. I'm only going to do the ones that are circled on the left, the odd numbers, if you will. And you actually see a bigger version of me than you normally do when it comes to me zooming out on the screen. Let me show you that right now. So you'll see that version of me. Hey, here I am. So we're only going to be doing the ones on the left. Now, in leading up to this, just keep a couple things in mind. And then I think this will make this go very swimmingly. And I think there are only 1, 2, 3, 4. Sorry, I want to count this out. I think there are only 10 problems. Excuse me. I think it's 1 through 19 odd and only 10 problems. My eye is suddenly bugging me. That or I thought of something really sad. I don't know which. So the couple things to keep in mind. Number one, and this is my old motto that I use. This is my substitution rule. And it is when in doubt. I'm going to write it out. That's not the motto. When in doubt, use your damn parentheses. And yes, I use damn. I use it for emphasis. I hope there are no little kitties watching. Use your damn parentheses. That is an R. This is for substitution-based purposes. Now, this is super important. Using your parentheses, now, it says when in doubt. So if you know how to not have to use them in certain circumstances, that is fine. But if you are uncertain as to whether parentheses are going to affect the results of your problem, use them. There are 3 reasons why you might want to use parentheses in a problem. Number one, so that way you can clearly identify to yourself that the thing that's in parentheses is what's being substituted for your variable. And I know that that kind of sounds weird as far as whatever else, but sometimes when there's a minus somewhere and then your variable's there that has a negative, sometimes people say that, oh, the minus is in the variable already and I don't need to have it there. It becomes a big mess. If you're uncertain, put the quantity that you're substituting for the variable in parentheses, and you know without a shadow of a doubt that the thing is just taking place of the letter, and everything else that is there should be there, if that makes sense. And I don't know if that's kind of that next aspect of number 2 that I wanted to say, really. I think I kind of just said it, but, then you know absolutely what is supposed to be where. So it's not just that you substitute for the variable, but you know what is still in place. If there is that minus negative, you kind of know what you're doing with it. And if you're squaring a number, it kind of changes the effect as to whether you're squaring something in parentheses as to whether you're squaring something that's not. And lastly, number 3, if there is a coefficient that's multiplied in front or 2 variables together, 2 sets of parentheses together, something with parentheses right next to a number or something else means multiplication. And then when you have the parentheses there to identify that with, it's not when it's multiplication, use parentheses. When in doubt, use parentheses, and then multiplication is one of the instances that you do it. So let's just do all those 3 things there. So that's another thing to keep in mind. And then the last thing I want to write here, of course, is Pemdas. Make sure that you understand the idea of order of operations, Pemdas or GEMS, identifying with the fact that things within parentheses prioritize themselves first, whether they're grouped and you add them, or that's the thing that you squared, as I said before, those things in parentheses, and then exponents, multiplication, division together, addition, subtraction together. Order of operations come into play, and then it's good. Now, the thing that I don't like about this worksheet is that the division sign's used. However, you got to know how to use it. But what I'm going to do for each expression that I see it, I'm going to rewrite the division as a, neck thing, as a fraction. So instead of the division symbol left to right, I'm going to write it as over. So I'm going to do that right now already. So number 1, let's go ahead and just get started. Evaluate each using the values given. We have the expression p minus r divided by 3. And then we're going to use p equals -4 and r equals 3. Now the thing, and I'm going to say it once and then I'll be done with it. I might restate it later, but I won't pause for it. This does say divided by 3. So the question is, are we doing p minus r over 3 like that? Whoops. Or is this p minus r all divided by 3? Now the answer is it's the one on the left. And the reason is because p is not being divided by 3. There is no instance which it's happening. Because of order of operations, division comes before subtraction. So I'm not going to subtract these first and then divide by 3. I'm going to divide by 3 and then do the subtraction. The only way that it would appear like this one on the right is if there were parentheses around this, something like that. or if it was actually written like that, if they actually had the problem that way. So the way that I want to write the problem is the p minus r over 3 like this, just to keep that in mind. Okay, next step is going to be the substitution. And each time I'm going to do this, just for point of emphasis, I'm going to use parentheses. Each time I'm going to have doubt, I'm going to use my damn parentheses. So let's go ahead and do that. So let's go. P is negative 4, parentheses around there. Negative 4 in for p, minus r is 3, and this is divided by 3. Okay? So this is negative 4. Now I don't need parentheses there. I've realized that parentheses had no further use for this negative 4, and it can then escape them at that point. That's fine. That's okay to do. But I used them because I was in doubt. That's not me, but you know. 3 divided by 3 right here is 1. So I'm going to be doing negative 4 minus, that minus is still there, 1. And left, further left, we get a bigger number that is negative. This becomes negative 5. That's the result. Okay. Number 3, as I skip the evens there, number 3, z squared minus x, we're going to use x equals 6 and z equals negative 4. All right, when in doubt, use your damn parentheses. So once again, the same idea here. Z is negative 4. Z is being squared. So negative 4 is being squared. It is very important they use parentheses here. It is crucial they use parentheses here. Specifically, you don't want to make a careless mistake, not put parentheses here, and either get the wrong answer or get the right answer for the wrong reason. Think about whether or not you use the calculator. To note, there is a difference. Oh, I didn't use parentheses here. To note, there is a difference between negative 4 quantity squared and negative 4 squared like that. Now, the minus 6 isn't going to change. Maybe I didn't have doubt. But there's a big difference between these two. The difference is this is negative 4 times negative 4. This is 4 times 4, where I apply a negative to it. So this answer is negative 16 minus 6, negative 22. This is 16 minus 6, which is 10. It's a big difference between the two, so it's super crucial you know which one. And to know, use your parentheses. Plug it in for your value. Close the parentheses when you're done looking at that letter. Negative 4 squared is 16. I just said this before. And 16 minus 6 equals 10. All good. That's it. Like I said, these problems can go fast if we know to use our damn parentheses. That's it. Use our damn parentheses. Let's get a different color here. Number 5. C, B minus B. Use B equals negative 3 and C equals negative 1. Okay, so this goes back to the idea of using your damn parentheses. I wonder if this thing gets rated PG-13 after I say it so many times. So CB, look, this doesn't mean, look, if I didn't use parentheses, if I strangely didn't do it, and I put negative 1 for C, negative 3 for B, and then, look, some people might do this. Minus 3 here, minus, it was negative 3, so minus like that. There is so much wrong with this that we gotta use our damn parentheses. So let's look at this thing again. Number 1 is the fact that these two shouldn't be subtracting. CB means that that's C times B. It means that they are already multiplying. And if you want to emphasize that one further, don't make me say it again. You can say it. Yeah, that. Use those. So negative 1 times negative 3 is going to be taking place there. And here's the other part. This isn't just minus 3. Some people sometimes ignore this minus because they're like, oh, look, there's a negative there. No. This is C. This is B. This is minus. This is B. See that? And sometimes the parentheses help because it helps identify with the fact that B is negative 3. I'm going to subtract B. And the parentheses emphasize that point just a little bit further. It does. So, all right. Negative 1 times negative 3, that is positive 3. Negative times a negative is a positive. Minus a negative. You subtract a negative, that's adding. That becomes 3 plus 3. 3 plus 3 is 6. And that is your result for number 5. All right. I'm going to keep going. Red, blue, purple. Red, blue, purple. Let's do that. Not red. I don't know colors. That is green. Oh no. I'm becoming colorblind. Here it is. It's called deuteranopia or tritanopia or whatever it is. Number 7, J times 2 minus K. Now, if you know the distributive property, there's another way that you could do this problem. I'm going to assume that you don't right now. Let's just do the substitution from this as it's written. J equals 4 and K equals 4. J equals 4. I have doubt, so I'm going to do that. Parentheses, 2 minus. I'm going to put K around this own set of parentheses as well. Kind of strange to have to do a double set to make that happen, but you know what? You're going to get problems that look like that. Maybe even some within here. I don't know. But there's nothing wrong with having that Look, they're nested parentheses within. Not that the parentheses really did anything here. I had doubt, and it looks like there was no real effect. So whatever, that's okay. Now, you might see this as doing 4 times 2 and getting 8. I'm going to color code this a little bit differently. I'm going to put red around these. These parentheses, though, go as far and wide as the past the -4. So keep in mind, even though parentheses go first. So that doesn't mean these parentheses with these ones. That means things within parentheses. So I'm going to keep this 4 here for a moment. I don't think I need the parentheses around it anymore, but I do need this set still. And I got 2 minus 4 inside here. That gives me -2. I have to do the subtraction first, unless I distribute, which we're not doing. Unless I distribute, I have to do the subtraction inside the set that's inside these red parentheses here first. That's what it means to do parentheses first within Pemdas. Compute all that's within inside, even if there are other operations that's less than multiplication, like subtraction. So that's what I did, and that's what we're going to do, and that's what's going to lead to a correct answer. 4 times -2, remember that's multiplication, because the parentheses there, that gives you -8. And that's the result. You could try a distribution route. Because I haven't taught it yet with my class, I'm not going to. Okay, number 9. Q, I gotta rewrite this. Q over 2 minus the quantity M, plus 6. Forgive my handwriting. What's next? Blue. Q is 2, M is 1. Q is 2, M is 1. Look at those parentheses. Now, I said I'd do them all the time. I think for the last 5, I'm only going to do it with reasonable doubt or concern. Like, I'm not going to do it here or here. I'm really going to do it with negatives and with things where there's multiplying and squaring going on. Hopefully that sounds okay. But I'm going to use them when I should be. And then you can start to learn when a good time. But when in doubt, use your damn parentheses. Okay. All right. 2 divided by 2 is 1. All right, so I have 1 minus, now inside this quantity, and I'll keep the first set of parentheses, the bigger set right there. 1 plus 6 is 7. Just giving you the idea, I got to do 1 plus 6 first. I don't want you to ask where 7 came from or why I didn't do 1 minus 1 first, because I got to do the thing in parentheses first. Now the parentheses can leave us. It's not really a big concern, and 1 minus 7 gives us -6. Okay? All right, what's next? Purple. All right, so number 11 here, and like I said, I'm only going to use parentheses when I have to, and guess what? I think I really have to use parentheses here. I mean, I'm serious, I do. So let's go and do that. R squared times P over 5. Now, where does the over 5 go? Does it go right here? Or does it go like this the whole way? You're inclined to maybe say one or the other. Guess what? The answer is either. It's both. Because multiplication and division are on the same precedence and tier of whatever's there, both of these are really dividing by 5, whether or not you think it. It's like if I do 3 times 6 divided by 3. That 3 really is dividing by... If you wanted to, I could do 3 divided by 3 and get 1, and 1 times 6 equals 6. That'll be the same answer. Think about it. 3 times 6 is 18, divided by 3 is 6. So the 3 is still also dividing by that 3 because of precedence levels. So I'm just going to write it all over 5. I think that's kind of a nice little way to do this. It's fine by me. It's cool. For the most part, you're not going to see this division sign when we do future ones. I kind of feel bad giving you it here. Okay. So here we go. -5 and -5. So, I have doubt. And you know what? I don't have doubt. I know for certain that I should be using my damn parentheses here. For the emphasis of I'm squaring R, so I got to make sure that when I square it, I square the whole thing, and I'm multiplying right here, especially by a negative. It's really, really important that you place those ones there as needed. Now, there are a lot of ways you can clean this one up, and I want to see if you can follow along with what I'm about to do here. -5 quantity squared, just like that negative, I don't know what the number was, 4 or 3 quantity squared, -4 quantity squared. I have an itch in my nose, itch in my eye, itch in my nose. I think I'm breaking out in some. -5 quantity squared is 25. That's my mustache. Okay, so that's this part right here. Now, I know you might be inclined to keep the -5 and stuff here, but keep in mind, these two are dividing right here. It's not a distribution of division. I don't have to divide both things by this 5 like I would with addition in between or something like that. No, I don't have to do that. But here, these two can divide right now. -5 divided by 5 gives me -1. Now, as a multiplication with this thing, that's a -1 that would go right there. That saves me time. I don't have to multiply 25 by -5 and then divide it by 5 again if I know that I can just take those two things and divide them together. So 25 times -1 would give me -25, and that would be the result. I feel really weird having this itch stuff. I want to take myself off screen with it. It's like, what's this guy doing? All right, number 13, x minus z over 5 minus 5. And because division comes first before subtraction, this is not part of the denominator in this quantity. So here we go. Let's rewrite that. Let's do x minus the quantity z over 5 minus 5. Okay? Those are not s's. There's no s in this problem. Green. I think green. All right, x is -5. I have no doubt about this -5 kind of sticking as is. I don't need parentheses. I'm not going to use parentheses there. I don't think I'm going to use parentheses in this problem except for the ones that are already there, if that's okay with you. But it's kind of nice to put them there to indicate this is where things substituted. Really, it is. I'm not joking about that. If you get really good at this stuff and if you're not teaching it, then you can do what I'm doing right now. So -5 still in front. And subtract. 5 over 5 is 1. So I'm going to subtract that 1 minus 5 quantity. Keep in mind, I'm going to do 1 minus 5 first. So 1 minus 5 is -4. Okay, now the parentheses kind of have some merit here, subtracting the negative. It's nice that I kind of kept them, and I had to, because I had to do the subtraction first. So that becomes -5 plus 4. And that is -1. If I did all the math right, that should be panning out just fine. All right, I got 3 more problems. Hopefully this was pretty fast enough as we're going through, and these ones aren't too long to make the rest too scary. Number 15, this division right here. So I'm going to do the rewrite. Keep in mind, no parentheses around this whole thing. So only x is being divided by 5. Okay? So I'm going to rewrite this as -6 minus y plus x over 5. Is it required you do this rewrite? No. But you're going to get used to seeing fractions more, so I'm just giving you that outlet, and you have the idea. Okay, let's substitute. Y is -3 and x is -5. -6 minus, I like parentheses in this case, especially with a minus in front. Well, especially with a negative. I like it with a negative and with an operation in any sort, really. I can't think of a time I wouldn't want to substitute without a negative unless it's the leading term. Maybe I'll do it then next time as well. Subtracting y, subtracting -3. Parentheses around that, crucial. I think they are. And even with this one too, you know, I don't want this plus -5 like that. That kind of looks hokey. I like that there. That looks good. All right, let's do some rewrites of some of this stuff. This is -6 is fine. Minus a negative is a plus, so -6 plus 3 right here, and then plus -5 over 5. -5 over 5 is -1. -1 is what is going to be added there. And of course, I'll do a rewrite for those. But before that, let's clean some things up. I can do -6 plus 3 right now and not have it affect this portion over here at all. And that's fine. That's totally okay. So -6 plus 3 is just -3. Add -1. That's the same as subtracting 1. So that's -3 minus 1, which is -4. Okay? I have 2 more. Did I say 3 more? 1 too soon? I can't remember. All right, so here we go. Oh, this one's already written. The next 2 are written as fractions. I kind of like that already. All right, so here we go. Let's substitute. 5, not going to use parentheses for that z right there, minus, I will here, -2 over 2, plus -2, parentheses, I like that, plus 6. Substitution first, clean up after. Here we go. We got 5 minus -2 over 2 is -1. Plus a negative is subtraction, so -2, and then plus 6. Here's where, let's kind of just do one at a time. I want you to be cautious when it comes to some things you combine. You probably can combine safely for the most part, but I want you to prevent accidentally writing 2 plus 6 and getting 8 and then subtracting that. So let's just do one part at a time. Let's start with the 5 plus 1. Keep in mind minus a negative. And let's go and clean this up slowly. 5 plus 1 is 6. 6 minus 2 is 4. And 4 plus 6 is 10. doesn't take too long to do a couple extra steps to avoid making mistakes, such as 2 plus 6, adding those two things together, ignoring the fact that there's a negative 2, actually, that's adding with 6. So I could have combined some other things early. I would have done that probably in my head in one step, but writing those out is also good. Okay, one more problem. Number 19. P is 5. I'm going to go ahead and put that around parentheses again for emphasis. The same idea with that thing. And minus, let's do negative 3 minus 2. Parentheses needed there. Yeah. I say the when in doubt card. I'm going to keep using that one. So here we go. 5 squared is 25. Minus, inside here I have negative 3 minus 2. That's a negative 5 right there. This is all divided by 6. Okay. Minus a negative is adding. All right. So that becomes 25 plus 5 all over 6, which is 30 over 6, which is 5. So if you do things right, all things clean up there. Oh, I do have one more problem. I thought it was 1 through 19. My apologies. It's 1 through 21. That's okay. We're getting there. We're getting there. All right. Last problem here. Z plus y. Okay. Here we go. Now, there are other ways you can clean it up if you know something about what's called combining like terms. Save that for the next video, or next 2 videos from now when it comes to combining like terms. Okay? Please. So let's just do the substitution. Z is 1. Let's do all parentheses this time. Let's finish off. Let's bookend this one. So Z is 1. Y is negative 4. Y is negative 4. X is 5. Notice I'm still putting the sign that's in between these. Z is 1. And Z is 1. Z is 1. All right. Anything that's a plus, negative, minus, negative, anything, I'm going to clean those up first. So 1 plus negative 4 is 1 minus 4. Now, you don't have to do this. Some people actually prefer it the other way. But at this point, I'm going to get rid of any parentheses that I feel aren't needed, which is now, at this point, all of them. One step. Let's do this all in one step. Let's see. 1 minus 4, negative 3. Negative 3 minus 4, negative 7. Negative 7 minus 5, negative 12. Am I doing this right? Negative 12 minus 1, negative 13. Negative 13 plus 1 is negative 12. So I get negative 12 for that answer there, and I am good to go. This one right here is an even numbered problem. It would be kind of a nice one to... Let me just show you what it's written with as a fraction. I'm not going to solve it, but this is important. We do not keep these in the denominator together unless there were brackets, parentheses, anything like that. This negative 6 divided by 6, these divide together just like this. This part multiplies with numerator stuff, so it would look like this. You do not put that negative 2 minus h down here with the 6 unless they were with parentheses together, because division and multiplication are on that same level. So I would divide first, and then I would multiply second. I wouldn't multiply first and then divide second, just because Pemdas shows it in that way. That's why GEMS is kind of used sometimes. All right, that's it. This was a homework assignment for one of my classes. That's why I just did the odds and did some problems with that. When in doubt, use your damn parentheses, use your order of operations. All will be set based on that. All right, well, thank you for watching this video. It was one of the shorter ones, if you will, 23 minutes long, where I just did a few problems there. Hopefully it all settled out. All right, take care, guys. You have a good one.